Hey, welcome everyone to Cotinix. I am Archo, and today we are going to solve the minimum numbers of flips to make this binary string alternating problem from LeetCode.
Wait a minute! Who are you?
Here in this problem, we'll be given one binary string, and in that binary string, we can perform two operations. And the type of operations can remove the character at the first and add or append that character at the end. Like it's mean if we have 0 1 0, then we can take 0 from the first and add it at the end and make it 1 0 0, like this. And in a type 2, we can pick any character from the string and flip its value. As it is a binary string, we can flip its value. If it have 1, we can make it 0. If it has 0, we can make it 1. And then we can return the minimum numbers of type 2 operations we need to perform to make the string is alternating. And the alternating string means that no adjacent string are equal. Means, for example, 0 1 0 1 0 1 0, but 0 1 0 0 is not the alternating string. I hope you all understand what you have to do. In this video, I will show you how you can take this solution from big O n square time complexity to linear time complexity O(n). So let's start this video. Here, if I take for an example 110, we have the length 3 string of 110. For this, the possible alternating strings will be either 101 or 010. These are the two possible alternating strings that can be formed with length 3 string. So we can say these two alternating strings as our target strings. So to appear from the input to this target string, we have to perform these two kind of operations. From that, if I talk about only type 2 operations, then we have to take the differences like 101 or 010. If I talk about the differences from here to here for the alternating one, then we have two differences for 101 differences and 011 differences, two differences in total for alternating one. This is alternating 1 and this is alternating 2, and for the 2 we have only one differences. If we talk about the type 2 operation only, then the minimum numbers of type 2 operation needed for this string to become one of this alternating string, then that will be 1. But if we take type 1 operations in our account, then we can say that if I take 1 from the start and add it in the end, then it becomes 101, and automatically it makes the alternating strings complete and our minimum numbers of type 2 operations become 0. So what we can understand from this example that we have to at first check how many types of type 1 operations we can take to make the differences of minimum, I can say, to make the type 2 operation minimum. So what we are actually doing, if I try to make clear with the example that is given here, that will be, that is 1 1 1 0 0 0. If we perform type 1 operation one time, then 1 comes at the end, then another time type 1 operation, another time type 1 operation, another time another again and again. Then ultimately what is happening, if we observe, we are actually duplicating our original string. We are actually duplicating our original string and make it double. So what we're actually doing here, if I try to explain here like this, then we are making one new string s dash from the same string s by adding it 2 times. That is the thing we are doing. And to make the problem from the time complexity of n square to linear time complexity, I'll come up at the later with that. But here what we'll do to find out the differences, how we'll find out the differences, we'll take the alternating strings at the bottom like this, 1 0 1 0 1 0, and alternating string, second alternating string here, 1 0 0 1 0 1 0 1, like this. Then again we'll try to look for the differences like this. But now here comes one twist. We will not perform type 1 operations again, because we have already taken understand that for the maximum types of type 1 operation we have to just duplicate our string. We understand that logic, so we have already taken that into our account, and we'll just now compare it. But we have to understand one thing, that our original window, if I talk about window length, we are talking about sliding window problem here. We'll solve this with the sliding window approach. For that we have to understand what is our window, or what is the length of our window. This original string, which is length 6, this is actually our window of length 6, and we cannot take 7 characters into our account or 5 characters into our account, because our window length is 6. This is our original length that is given, that's an input. So that is our window. So at first we will calculate the differences for the first 6. This is our first window. Then after performing one type 1 operation, this becomes our second window. Then after performing second type 1 operation, this becomes a third window. Then this up to the end of this. These are our windows that we are getting after performing type 1 operations. Now for each and every window we have to check for the differences, and at the end we have to find out the minimum numbers of differences. But let me ask you one question. Here comes that part, how we can make this into from the n square time complexity to the linear time complexity problem. Here comes that clever part in our coding part. If I am only changing the first element, that is this element, then why I have to calculate again for this 5 elements? Because I am already calculating one time, then why have to again calculate all these 5 elements? Instead, that can't I just calculate the difference of this element that I am altering with the type 1 operation? This means only this one, after that this one, after that this one, then this, then this, then this. If I do that, then our time complexity become one time complexity. That means after performing whole thing, our time complexity become linear time complexity is O(n). So what I'm saying, that don't try to calculate the remaining 5 things, calculate after that.
One eternity later.
Sorry, my camera actually charged out in between. Let's start it where we're doing. So what I'm saying, we have to take this window and slide this window from one corner to at the end of the other corner, and we will not take account of this middle elements, as we are just only altering one element. If there like this, if I am saying here is one difference for this one, if this makes one difference diff by 1, then after altering it to here, this difference will no longer exist. If we are not checking for this one, if we after checking for this one, this maybe after comes 1, but if I cancel out this, takes out this first element and add it at the end, then automatically it clears out the difference by 1. Okay, so this is going to be our approach. Now let's code this all thing together. Let's code this out. Give me 1 second.
A few moments later.
So let's start our coding part here. At first I'll take the length of the original string s. Then after taking the length of it, I will make the string double it. After that I will make two alternating variable, alt1 and alt2, for my two alternating string or the target string. Now make loop for making the alternating strings. Yes. For making the alternating one, I will print 0 if my value comes even, and I'll print 1 if it's odd. If I'll do exactly opposite with alternating 2. I'll do exactly opposite with this one. Okay, fine. Now I'll make one element res that is going to give me the maximum fleet that holds the maximum flips value, that is the maximum lane of the s. It can be the maximum. Now I'll make two element for the differences, diff1 and diff2. Done. And now for the sliding window, I have to check for the left corner and for the right corner, or both the extremes, for making my window and to slide it throughout the end, through the end. For that I will drag left corner with L, and right corner will be shifting, so it will be in my loop range. So for the beginners who are watching this, I am telling that the length of s that I am setting here, that is not 6. 6 I am telling for the example 1, with respect to example 1, that is not 6. That will, as we are multiplying here, s is equal to s plus s, not multiplying, adding s 2 times, that where we are making the length of the string twice as it should be. So you should understand that. So now after doing that, I will check for every differences. For that I will come up with this. I'll check with the differences with respect to alternating 1 at first. if we found one differences with alternating one, then I'll increase the diff value by 1, and the same thing I'll do with diff 2 and alternating 2. Now we have tackled with our finding a differencing part. Now I will check for r minus l plus 1 is greater than n or not. If it is greater than n is our initial length of the string. If our sliding windows r values becomes greater than n or our original string, then we'll increase the left corner by 1, so we'll shift by 1 element. So actually it will be considered as we are performing the type 1 what algorithm by one time, of type 1 operation by one time. Okay, if s n not equals to alt 1, same thing here. After checking, after performing type 1 operation, as I said, we will not come back to the previous 5 element. We will check the alternating element if there was at previous time before alternating, if there was a difference or not. If there is a difference, that will no longer exist. That's why we'll make the difference decrease by 1. That I am doing. One. Same thing I'll do with the alternating 2 and diff 2. Now after doing this, I will update the L value by 1 because I have to shift. Sorry, it should be here, not there. Now after doing that, when our alternating string or our sliding window reached at the end or at the most right extreme, that time we will check the minimum value of diffs. I told diffs because by taking account of diff 1 and diff 2, that way. Let's just check. We will return the minimum of this two. Res diff 1, diff 2. Now I will just return this. Return res. So this is our program. This program just shows how we can just take simply the brute force solution and make it to a clever linear time complexity solution by just making one simple difference of not taking account of this thing of repeating one thing twice there and taking the approach of sliding window. I hope you learned from this video. If you enjoyed this video and want to learn more problems about LeetCode, then stay tuned on this playlist. I'll try to update and upload more and more videos about LeetCode problems and about its optimized solutions and many more things and many more tech talks is going to be written on this channel. So till then, stay tuned, stay focused and build code, stay creative.